Okay, guys. Uh, Thank you for all being here. Uh, I would like to welcome George and sorry for saying your name wrong, but mm, could you say it for me?
Alexander. Alexander is
Alexander.
my name actually, but
Okay.
it's
Sorry, your username was different. But
Mhm.
George and Alexander, they're working at T-Mobile in Austria, right? And
Yes.
they are going to show how they are using Pixi to boost their data science and software development within their company. Yeah, really thank you for
Huh?
wanting to present with us, and I hope we're going to have a great presentation. I'll start
Awesome.
using your screen.
Thanks for introducing
Okay.
us. It's basically the first time we're sharing this, what we're building for a large round publicly. So we are a bit nervous, bear with us, but I hope you will enjoy it. So what we are building here is we're building our new cloud-based data platform for telecommunication carrier in Austria. And we will start by sharing a couple of fundamental principles about what is important for what we are building. And then Alex will deep dive into the individual components of what are part of this data platform. And then we will finish up by, clearly stating the advantages that we are having by using Pixi.
Sure.
So let's move on and briefly introduce us. So I have here Alex with me. Alex is actually sitting in the office, and I'm Georg, and both of us are very data focused. Alex is sort of implementing a lot of stuff for our main data platform, and I'm more on the architect side. We have included a lot of links, so yeah, please just join us, join our discussions, and give us feedback. We are more than interested in hearing what you think about the ideas we will present in a minute. So, our data platform has grown over the years. There are so many tools, and the data lineage and the data dependencies are not explicit. In fact, there are many different tools competing with each other and transforming data. One could say it looks a little bit like this internet poll in Asia. So it's very chaotic and very, very painful to debug any of the data pipelines. And our main goal when greenfield rebuilding our new data platform is to fix something like this, to make it easy to develop high quality data pipelines and even doing that efficiently. So please move on, Alex, to the next slide.
Sure.
What are the pillars that enable this? First of all, a key element here for us to have the right metadata in place to make sure we only have, well, data pipelines that are legal and not illegal. That is from a governance perspective. But from a technical perspective, you remember the chaos from before. The explicit data lineage is missing. Normally, humans, especially children, when they go to school, eventually realize the human brain is not ideal for multiplying large numbers. Instead, they use a calculator. Interestingly, with task-based data orchestrations tools, like for example Airflow, this is really hard because, again, it is task-based, so we don't have a graph of the data dependencies. We can only schedule individual tasks. So even if we would be rebuilding with a task-based orchestrator, we would be very soon end up in a situation that we are starting out with, a situation where we don't want to live in. So what we are changing is we're creating the right data structure for our data pipelines in the sense of we explicitly model the asset graph of data dependencies, where each node is a state we care about. We call that a data asset. And every connection is the transformation that goes on from the initial state to the transformed state. And by having these explicit data dependencies and building on an orchestration tool that is named Dagster, we can work with this graph. We make this graph transparent. So any ingestion activity, any transformation activity, even BI dashboards, and any AI activities are part of this graph. What does this enable? First of all, it enables us working with this lineage efficiently, backfilling and reconciling the data efficiently. It increases our data quality. But on a second order, it allows us to work with event-driven coordination. Imagine one team that provides reference data, let's say address data, and a second team, a marketing team that wants to consume this data. We can then link them, and basically once the address data refreshes, automatically update the downstream consumers. Why is this so important for us? Well, in the old world, we didn't have this connection. We didn't have this link. So basically we were just waiting for a very long time, a couple of hours, to make sure that the source system delivered the data successfully, and then the consumer would eventually, based on our crunching, pull it out. There's a lot of waiting involved. It's slow, but also very error prone, because sometimes the producing system is delayed. Thirdly, this enables us to break down tool silos. That means make the individual tools collaborate via this asset graph, but also the humans and teams, because we're now more interlinked than before. Let's move on, Alex, to the next slide. So, yeah, I was just talking about all the things, so we'll be a bit faster here on the slides. Yeah, this is the calculator topic. So it allows us to reduce the manual errors by having this calculator of the data dependencies. Alex, let's move on to the next slide. The event-driven coordination. This means we don't have to wait anymore. We can eliminate these waiting bottlenecks and have overall a better synchronization of the state if data refreshed in some part of the data platform and how it then trickles down downstream. And the last pillar is this team pillar. And this is quite an important one for us as well, because in the past, the data part was isolated to specific power users. But with the advent of more SQL again, we can enable more people to participate easily in the data journey and share their own reports easily and integrate them onto the mainline data platform. So this allows us to build something like a playground where we as a platform team bring the toys and people can then join in and have a fun time creating sandcastles. So we're reducing the team silos by following these principles. Let's move on, Alex, to the next slide. Okay, so a brief overview of how this data platform is structured. Well, we have various data sources. Some are APIs, some files, some streams, some traditional RDBMS database systems. And we're ingesting these into our data platform. And in the end, publishing this as dashboards for consumers or perhaps even downstream services of IT microservices. The ingestion is performed via a custom framework that we have that is built around Spark, that is asset aware or graph aware. And from there on, the orchestrator kicks off the transformations inside of the data platform. Here we're using dbt for the most part of the transformations. The orchestration itself is something that is happening around this asset graph of explicit data dependencies using Dagster. Okay. Alex, I guess
here. Yes.
I would like to hand over to you to move forward with more details of how we make this asset graph scale and how it works in detail and why Pixi is such an important element for us there.
Exactly. Thank you, Georg. So, Georg kind of explained the high-level concepts, which are the concepts on which we are building on. And basically, what I will now try to do is I will try to explain the low-level implementations and tool stack, how we are actually building those concepts in the real physical world. Yeah. This picture is basically just a high-level representation of our platform, where we go from the very left ingest into the platform, doing some transformation, and then providing the data for the upstream consumers of our platform. And as Georg already said, is that we are heavily building on top of the asset-based orchestrator Daxter, and that Daxter is actually integrated in every and each piece of the end-to-end pipeline, so to say, on top of our platform. And I would say this picture is actually representing the core of one data engineering process in general. Yeah. Now, if you take a look into this process, and if we kind of say, okay, there is ingestion, there is a transformation, and we orchestrate, we can say the process is relatively straightforward. Yeah, we just ingest, transfer, and then use the data. But what we never have to kind of forget is that everything what we do, we are actually doing to provide better service, and we are doing this for the business. So how this looks like in a company is basically, okay, I have a data team, and I have, or this data team has a project which is basically in some moment of time earlier started in some I would say with some data analyst in some business unit. So basically they had a request to improve the service, and basically they are coming to the data team and they're saying, okay, I want to do something with my data, please do something for me. Yeah. But over the time, there is second unit, there is third unit, there is fourth unit, and basically you can imagine how an enterprise is growing in the business. So the business units are also growing, and then what a company normally do is they introduce the second data team. Yeah. So basically, if you can imagine, it's very hard to scale across the company because we have a lot of the business units, and all of those people want to do the same thing, is to make the value out of their data. Yeah. What is then happening is that another data team is saying, okay, I have a project. Maybe we have a together project, but you can imagine that over 10 people in a team you can go. So basically, it's very hard to go. And what is then happening is it's happening that you lose the way to follow what people are implementing, and basically inside of one company you have then one or two or three different solutions for the same straightforward process which we were looking at earlier. Yeah. What we then started to do, or how we kind of try to tackle this problem, is basically we ask ourselves, okay, how we should think about this process in order to be able to maybe also push the projects to the business unit itself, and basically support our data team to kind of scale throughout the whole company as the company. Yeah. What we then did as the first step is we separated people. So basically we took a few of them and we said, okay, you are now not interested in value or extracting the value out of the data, but you are actually interested in order to kind of create the frameworks and to create the environment for the people who are then extracting data. So basically we in Magenta, in Telekom in Austria, it's called Magenta. So basically we believe that not everybody can know everything about this process, because either you know about the business or you know about the technology itself. Yeah? And the other group of people, so basically the group which were already there earlier, is users of this framework. Yeah? What we then as a data platform team, so basically me, Georg, and other colleagues which are in the data platform team, what we are doing, we are basically saying, okay, we provide you the template project, and basically all other projects across the company or across our data landscape should potentially follow this template project. Yeah? How this looks then is basically that we develop a feature. We say then, okay, you can now ingest something else from some other source system, and we explain you how to use it, and then the people in the usage area, so basically in the people of the group which are filling the content and extracting the value, they are then using those features. What we are also doing is basically we are providing the project infrastructure for this, I would say, platform. We call it data platform, and basically we are providing the pieces which you can build on top of this platform. What is important to say there is that you have to think in a building block structure. So basically what this means is that this template project is actually something what is enough to be on its own. And it doesn't matter if you have 1 or 10 or 30, everything is exactly the same. How we solve this, or what is actually in the background of this, and this is where Pixi also comes into the game, is basically we are introducing the modern tooling around those projects. We are building heavily on top of the Daxter, dbt, Pixi, and Docker. Yeah? Now what I will do in the next slide is basically explain how the landscape of one template project or one instance of the template project, what is there inside. Yeah? What is a building block for us? Again, the same process. So basically with one building block, you are able to do a process from the ingest till the serving the data. The first thing which we have to say is Daxter is the core of our platform. Of course, in order to kind of use Daxter, we need Python environment. So basically Daxter is sitting on top of the Python environment. On top of the Daxter, we have multiple Daxter integration, which are basically dbt. We have some visualization integration. We have others too. Yeah. What we have also is the custom code of the Python. So basically, as every orchestrator, you can define your code. Basically, this is something what the AI group is using and so on. Now, because we are in a big enterprise, we had also earlier the big data part of the team. So basically, what we have is a lot of the I would say code which is written in other languages than Python. So basically, we have a lot of the Scala written at home. So in our company. So basically, we try to reuse as much as possible, and we kind of took a piece of pieces of this old code. So basically, of the current code which is running on the big data cluster, and basically we integrated into the Daxter. But in order to run Spark in I would say local mode or in the cluster mode, we needed some kind of Scala or Java environment. Yeah. What is also important, those pieces are basically something to use from end to end, but we have to also understand that there are other stuff which we need for development. I don't know, inside of the environment, inside of the curl, maybe somebody wants to develop in Vim or do whatever he or she wants to do. Yeah. Or basically we provide you a environment where you can explore the data, yeah, basically, or do whatever you want to do in a notebook fashion. And now is the question, where is actually Pixi in this game? Yeah, Pixi is actually sitting on under all of this. And basically we are using Pixi as the, I would say, maybe some people are calling it package manager. I would say for us, it's actually environment manager. So basically that Pixi as a tool and Pixi tasks as a kind of part of the Pixi, we are basically inside of one file of pyproject.toml, we have everything what is needed in order to create everything of those. Yeah? We are not currently using, but we are basically planning to use also Pixi globals for basically installing extra stuff inside of the environment if you need to. Yeah? This is something where we are looking forward. Everything of those toolings is then actually packed inside of the Docker, and it's one piece of software which is basically able to deploy, and which is then basically one building block which we are using for one team. And you can now imagine how we can actually scale this. This is in general. What I will now try to do is I will explain at least two use cases of the Pixi inside of this. So basically, the first use case is feature selection. What does it mean? It means that not everybody needs the whole building block. Not everybody needs Jupyter Notebook and Ingest Framework potentially. So basically, if I say I want just to play around, I can basically take just a part of this, and I can just select a feature, and I can say, okay, install me just the Jupyter environment, and this is everything what I need. What I also can do is I can say, okay, I want everything. Basically, this is option also. What is also option is that for the production load, so basically for the very last step, when this is running in production, we can say we don't need everything what is development. Yeah. And basically what we also can say is not every piece of the project is actually using ingest framework. So basically we can get rid of Spark, PySpark, and so basically Java environment on its own. So basically we can rip off a lot of the Docker image volume, so basically some megabytes, in order that it spins faster, it's there. But if you need, you can always go back and you say, okay, I need this feature too. Yeah? This is where the Pixi is holding the environment and feature selection for us. The next use case is the use case of the log file. What is here important to say is that people always say about the log file is, okay, I install it on my machine and it will work on your machine. And this is the main usage of the log file. But what we are actually using is we went a step further. So basically what we are doing is we have a template project. And basically what we are doing is we did an instance of this template project, and we actually develop inside of this template project. So this is where we do new developments, new features. So basically this is a home of data platform team. Yeah? And what we are then doing is basically we are resolving the environment. So over the development cycle, we are resolving the environment, and we get some Pixi log file, which we are then putting back to the template, and then we are propagating those files inside of all the projects across the company in order to force them to use the newest tooling and newest feature what we basically provide as a platform team. What we are also doing, I mean, what we are using for the templating itself is the library called Craft. And basically what is there important to say is that this is not one-time shot. So basically it's not that I'm making an init of a project and then leaving it as it is and then they can diverge, but rather you can update the main project over the time. Yeah? So basically it's also very important to kind of see that we use a Pixi frozen environment variable because not every project can resolve. Yeah, and this is very important to see that projects which are basically in the hands of the business units which are hands of the users of our template project, they are actually not able to resolve. They are just static one which are getting always over the time as the template project evolves. Yeah. Those are two use cases. We wrote a few more. So basically, what I told Georg earlier is that when he wrote advantages over the old system, basically I said I don't want to compare it at all. Yeah, I just want to kind of say what we are using it, and basically it's for me it's a totally new system which is there. Yeah. For what we are using it is log files. Basically, this is what I explained. What is also a very big advantage is the speed. We used Conda earlier, so basically we reduced a lot. I don't have to speak so much about this. Something what is not maybe visible, but something what is very important are also Pixi tasks. So basically we are preparing and doing everything in the environment what is needed as you would it with a make file. Now you do it actually inside of the Pixi. And what is very important there to understand is that it's not just a make file, it's also a kind of preparation for the environment. So basically I can run a task in one environment or another environment, depending which features are actually there. So basically, if I have Jupyter Notebook, I can start it with the Pixi tasks. And if I don't have it, then I don't do it. Yeah? This is something what is a bit different than the makes file itself. The feature environment-based dependency, this is something what I was already speaking, and the multi-language environment is also something what is very appreciated from our side, because we have a lot of the custom code, and you can imagine how we would actually have to install a Java environment inside a Docker image, which is actually based on some Python environment. So basically, those will be extra step in the Docker file, but with the Pixi itself, this is actually just one pyproject.tom file. Okay, the last slide is basically everything what we showed now here, or what we were speaking about. Georg is maintaining in some open source code. So basically, if you go to the Git and you go to the local data stack, this is a template project. It's not as enterprise as ours, but it has the base, I would say, base features which we are also using in the background. So basically, they are kind of connected. And the second sentence which I want to kind of say is, what we are building is actually a teamwork, and we are really proud of not just our data platform team, but also around our team. So basically, all the people who are supporting us and using our frameworks, because we know that it's very important to kind of that usage is also visible, and that at the very end, if I come back to this first sentence, is we are doing this for business, yeah, and yeah, we are very proud on what we are building. Yeah? Okay, I will hand over this back to either Georg or Ruben.
Yes, one remark from my side. Also want to say thanks to Pixi. It is actually working super fine for us. And if there ever is a small issue coming up, it was always getting fixed very swiftly.
Exactly. So,
with that being said, I don't know how live our live stream today is and how many viewers we have, but are there any questions in this round or from the Pixi team that we should go over and address?
We are actually live. I can check if there's any chats coming in. And I don't see anything yet. But we'll leave the chat open so people can still ask questions. But thanks a lot for presenting how you use Pixi. I think it's a perfect example of how Pixi can be powerful. Because just going out of the Python only world is a big problem for multiple companies, and I think this shows very well how you can do it. Also, thank you for presenting the extra stuff that you use to get a full-fledged environment. It's very informative and also helps us understand where the code is used, or Pixi code is used, so we can focus on it more. And I have seen specifically Georg a lot in our issues, which is perfect because then we know what to fix first. And I just want to say thank you for working with us as well, and not just being silent users of Pixi here.
Exactly. What we had a lot in the background is basically comparing Pixi to something, and like comparing Pixi to some Python package managers and so on. But this is actually more than this, yeah. And this is very important to kind of say that we kind of felt, okay, you have a file where you can define everything what you want inside of your environment, and the only thing which you need is a kind of base Docker image where the Pixi is installed, and you can start then from there and go into the whatever you want from the perspective of environment, yeah. This is a very unappreciated situation, I would say, and not kind of seen in a lot of scenarios, because people are just in the Python world from that perspective. But when you deal with, I would say, extra Java or extra whatever you have to install, so basically it's not so hard, not so easy to kind of just run the Spark local and it will work with all of the libraries and dependencies and whatever is there. Yeah, basically it's something where we struggled a bit, I would say, earlier, but now it's kind of started to be much easier, yeah, from the moment when we are using Pixi.
Perfect. Very good to hear.
Are there any questions rolling in, Ruben?
I haven't seen
Yes.
any.
I saw the hands here, at least.
Thanks a lot, Aleksandar and Georg, again for presenting. I think what you do is basically, at least what I wish that people would use Pixi for. You have a data science background, you use multi-environments, actually quite complex ones. And you even have multiple languages, Python as well as Java. One thing that I wondered about the presentation, you briefly mentioned that, Aleksandar, was that you rely on Pixi Frozen, which I found curious because I always wondered who the hell is using that, because that feature I never considered it particularly useful. So could you maybe elaborate why that is useful for you, why it's even necessary for you?
Yes, the thing is that this is a very good question, because this is something what we kind of found out that it's very useful for us. Is if I go back to this slide where you see the this one, okay? If I go back to this one, and you can imagine that actually we don't want what happens in the Python world is normally, or what we do also, we have a shared library as a shared code which we are doing, and we develop this on the so to say, I would say on some big base or something. But what we don't want to do is that every package or every project which is using that is actually using the newest library, because we have dependency on top of the environment. So basically on top of the Docker image and on top of the code which is written there. So basically for what we are using the Pixi Frozen is basically to freeze the environment of our users, in order to kind of give them, you just have to download all of those stuff, but you don't have to resolve it again. Because what we are doing is we are actually resolving or while we develop. And when we actually went through the tests and everything what is there on our side, then we say, okay, we are sure that that the environment will run. And basically we are providing this into the template, and then we are pushing this to the users. So basically we don't want that all of users have the newest packages, also if this is the minor or whatever version there is. But we want that just the platform team has I would say leverage over the updating the packages, and that we have actually the control over the environment itself, because they are just using potentially DBT, and they don't care about Duckster or Spark version or whatever is version. They care about features. And when I say they, it's like the users of our template project. Okay, makes sense? Or
What would happen if you wouldn't add Frozen? Because it sounds to me like everything you want would also happen if you wouldn't pass Frozen.
So it's faster, because sometimes we have some enterprise-grade, very secure proxies that can make things a bit slower, especially with some ongoing introspection.
As I understand the resolving is basically in some of the minor versions you can update your packages while you resolve. And basically what we are doing is we are saying to everybody, you can't resolve. Basically
it is ignoring the manifest. Like no matter how you change your Pixi toml, it will, at least if I understand the docs correctly, it will only take whatever is in the Pixi toml and will ignore your Pixi toml and will only take the log file.
Yes,
I think there's one in-between step we're forgetting here, and it's currently kind of seen as a bug on Pixi, and we're working on to getting it fixed. But if you use a PyProject.toml, that is part of the log file. So if you then change that file, you are also going to resolve. And using Frozen will skip that part. So you're going to ensure that you have a very fast startup of your environment, even though you might touch the PyProject file.
But as I understand, in the PyProject.toml, you can also define some what is the ranges. So basically, we don't fix the packages itself, but we actually give some ranges, and then inside of the log file, you actually fix the version itself. And this is also where we are using this, because we have some shared library which we are actually updating with some minor versions or whatever. But maybe this introduce some problems for the end users, and we just don't want that they are kind of aware of this, but that we are actually controlling this updating of the log file.
Yeah. So it's mainly about the responsibility, like we as a platform are building this playground, and users should have a smooth time there to enjoy themselves and the data.
Exactly, because the people who use our project itself are not the people who will understand Pixi resolving problem in that sense. Yeah, and we just don't want that this happens, and this is fine. Yeah, but from that perspective, we don't force them to use, and we basically what we do is in our instance problem we put the Pixi frozen false. We do whatever we want to do, and basically on the all other instances, so basically the default value is true, that everybody, you can of course switch it. We had also the problems for some AI use cases where they wanted to resolve again. So basically you can switch it, you can resolve, you can then push your pixi.log file and not update it anymore from the template. So basically you can diverge if you want in the Pixi log, but per default it's not allowed. I mean,
okay, but when you diverge, it's basically on your own responsibility.
exactly.
Okay.
So
Yes.
I have another 2 questions. Thank you for the presentation. So you're using Java, and I know there are not that many Java dependencies on Conda. So are you using like a separate log file to log the Java dependencies? That's my first question. And the second one, just to like put it after it, is how do the end users run? Do they also use Pixi, or do they use something different because they might not be comfortable with the command line or something? I assume.
So I
those are
think
my
let's
questions.
unpack this into 2 parts. How do your end users run? So we have 2 modes of running this data pipeline basically. One is end users as a developer or some SQL analyst that want to work in their DBT project. They can basically just either start a Docker container and then work, but we are currently also working on rolling out something similar to a GitHub Copilot. So you can just log in, and similar to logging to your Outlook and reading the emails, you can log in and get your work done with regards to data. And you have a second mode, that is the production grade pipeline, that is hands-off and fully managed by the orchestration engine. I hope this is answering the second part. And with regards to the first part, we have some standard Java projects with Gradle or Maven that in the end produce the necessary jars that we need. And from Pixi, we just get the runtime of the right version of a JVM that fits that particular use case.
What we are doing also with the Pixi task is basically playing a bit around inside of the dependencies. So basically we are adding or deleting some of them which are actually needed. This is not maybe ideal one, but actually Pixi tasks are helping us there. So basically deleting or copying something over what is there. Yeah, this is not always maybe a great idea, but for now this is the case.
So what Alex refers to here is that during the setup process of building this container, there are a couple of steps that have to happen that should work, irrespective if it's done in Docker or not. And where Pixi tasks are very convenient to copy the jars into the right locations and so on many different systems.
One example is you have a Guava from Google Cloud Security part, and basically you need a better version which is not in the PySpark which we are using, and basically those combinations are kind of some where we are tweaking some jars which are not needed, or needed or updated versions are needed.
Yeah, I asked a question specifically because sometimes we are discussing like should we tap into more ecosystems like similarly as we do to PyPI, or like get more stuff onto Conda, and there's like a lot of C++ stuff on there, like that's something we worked with in the past with robotics, which was like convenient that it was both the Python and C++ things on Conda, or that you could at least so I guess Java is a bit more second party than first party. So I was wondering, would it benefit you if you could like be more explicit with the Java dependencies in the Pixi toml, or is it fine as it is?
Alex, do you want to take this one?
I never thought about this one, I have to admit. So basically, I can think about this. We are right now fine. I would say running Spark local inside of a Docker image with on top of some proxy settings is not easy task. And basically, this is somewhere where we had a lot of tweaking in order to work. If this Java depend, the problem is that we are actually we use PySpark as the Python dependency in that sense, and then this is downloading everything what is in the. So basically, it's coming with some default jars. And the question is now, okay, should Pixi now know to go to this place and remove this jar and add a newer version? This is, I would guess, a very hard task to do, because it's basically, then we are again in PySpark world, and there are some jars where those combinations are not right. Yeah?
Yeah.
It's a bit, I would say, on our side, is still not optimized topic. Basically, we made it work, and this is something where we will for sure take a look into, but we kind of organized ourselves more about the core end-to-end pipeline and kind of allowed it that it works. But in the future, I would guess that where we are going into is basically, we decided for Spark because it's main thing in that sense, and we had a lot of code around Spark, so basically custom code too, which is basically for our specific stuff. We want also to explore other stuff for the ingest framework itself. So basically a smaller stuff which are then running in memory for smaller parts. I don't have to run Spark for everything. So basically, this is where we are going into, and then using Spark just for the big stuff. But this is something what will take over in the future when we optimize. Yeah. Right now is not a focus.
Thanks.
Okay, thank you. I think we're going very far over time already, so I would like to wrap it up. If there's any more questions, please ask them in chat, and the community is of course still open to answer more. And I would like to thank Georg and Aleksandar again for their presentation, and hopefully we can work together more in the near future.